just for the video's sake, we're using a distance formula to find distance first. You label your points x1, y1, and then x2, y2, just like you would slope. And you take those values and you plug them into the correct spot in the formula. Then what you're going to do, you're going to plug everything that is underneath the radical. You're not going to include the radical. Plug it into your calculator exactly how it's written, no different. Parentheses 6 minus 2, close parentheses squared, plus parentheses negative 8 minus 3, close parentheses squared. This is exactly how it looks. What do we get? 137. Right? Just in case it asks you to leave it in simplest radical form, can we break down the 137 any further? No, 137 is a prime number. So that's it. Okay? If it asks to round, what do you get when you do the square root of 137? 11.7. Okay? Not a lot of work involved with the distance formula. You just write it down, you plug it in your calculator, simplify if you need to, and plug it in around. Okay? Hard part is you have to know that. You have to have it memorized. Okay? So let's say you sit down and study, you have it memorized, and you get to a question like this on your test. You're like, oh my gosh, I don't remember the distance formula. Okay? What you can do is you can use the Pythagorean theorem. This is how I taught distance. I think other teachers teach distance in geometry. So you're going to make your own little grid and plot the points. So here's 2, 3, and then we're going to plot 1, 2, 3, 4, 5, 6, negative 8. You have this, and we're trying to find the distance of this guy right here, this segment. Okay? Well, what you can do is you can just make a right triangle and use Pythagorean theorem. Because we all pretty much know that pretty well. So it's been ingrained in your brains what the Pythagorean theorem is. So we can use that when we're looking forward. Just make a right triangle. Here. Okay? The slanted side is always going to be your C. That's always what you're trying to find. You notice these are nice and straight lines. We can easily just count them or kind of do the math to figure out the distance. Okay? Well, if we count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the distance of that side is 11. Count the same way, or you can think, well, here's this point starting at 2, and it's going to 6. So what would the distance of this side be? Went from 2 to 6. 2. What is it? 4. Then you can just count. 1, 2, 3, 4. Okay? 4. So those are your legs. So remember, what's the formula for Pythagorean theorem? A squared plus B squared equals C squared. And you have to know that. Most of us do, like in your brain forever. Okay? So then label the slanted side you're trying to find. Where that connects your 2 points is always your C. This is your A. That's your B. Plug it in. You're going to do 11 squared plus 4 squared equals C squared. Again, you can just plug this stuff in one step. What's 11 squared plus 4 squared? 137. What do we have to do to both sides? So C is equal to, or your distance is the square root of 137, which is about 11.7. You get the same exact answer. Okay? Distance formula might seem easier because it's so much less work. It's more plugging things in your calculator, but you have to have it memorized. So if you're asked to find distance and you don't know the distance little grid. And that's the points. Make a right triangle. Find the legs. By just counting. Plug it in the Pythagorean here. That's how I did distance. And if you're currently taking geometry, I think that's how you do distance. Questions over that? Okay. Midpoint. Right, here's the formula for midpoint. It's exactly right in the middle between 2 points. Like a dead center of a segment. To find the midpoint, again, you use that formula. Again, you have to have it memorized. How I like to think midpoint formula is, you're just finding the average of the x's and the average of the y's. That's all you're doing. Because remember, when you find the average, you're finding the middle, right? Of the numbers. Well, to find the middle, you just add up the numbers and divide by 2. So, to find the middle of the x's, you just add the x's, divide them by 2. It doesn't matter the order. Just add the x's, divide by 2. Do the same thing with the y's. Add the y's, divide by 2. We already have them labeled in these points, so what are our 2 x values? Okay, so just add them together, divide by 2. What are our y values? 3 and -8. Add them together, divide by 2. What's 2 plus 6? 8. And what's 3 plus -8? 5. Over 2.
Miss Queenie, you want to leave that decimal form?
I would just know how to do both, because I don't. It's going to be multiple choice, and they might have it as decimal, they might have it as fraction. So I would do fraction form, because to get the decimal form, you just divide it in your calculator. It's harder to go from decimal to a fraction. So what does 8 over 2 simplify down to? 4. Does -5 over 2 simplify? No. So leave it as -5 over 2. Just in case, so we know how to look at it both ways. Your answer might be a fraction, but it might also be a decimal. What's -5 over 2 as a decimal? -2.5. So if you're doing the midpoint formula and you get this, but all your choices are in decimal form, just do -5 divided by 2. -2.5. Questions over there? So now, we have a pretest question, which is on your pretest. In the standard xy coordinate plane, what are the coordinates of the midpoint of the line segment whose endpoints are -3, 0, and 7, 4? Well, essentially we said when we're finding the midpoint, we're just finding the what? The average. Average of your x's, the average of the y's. Make your point. What are our x values in those 2 points? -3 and 7. Here's an x, here's an x. Add the x's, divide by 2. What are your y values? 0 and 4. So add your y values, divide by 2 whenever you're asked to find a midpoint. Add your x's, divide by 2. Add your y's, divide by 2. And then simplify it down. A lot of this stuff you can give a graphing calculator. Just do alpha y equals, and you can plug this in one step. What's -3 plus 7? 4. So what's 0 plus 4? 4. So simplify it down again. What's 4 divided by 2? So both of these are going to be 2. Our answer is move both ways. Circle. Questions over there? No? Here's the refresher. Geometry concept. Excellent rule. 1. We have x to the 0 power. So when we go to simplify that, we easily reference that box. Anything raised to the 0 power is what? 1. So our answer then would just be 1. If we look at 2, you notice in 2 we're raising a product to a power. So look at your chart. Find in the box. Number 6 is something similar. The exponent was on the outside. What does that look like we did with that exponent? Distribute. Everything's getting raised to that exponent. So if we look at number 2, 8's getting raised to that exponent, and x squared is going to be raised to that exponent. So we're going to say 8 cubed times x squared. We have to keep cleaning it up. We're not done with it. What is 8 cubed? Kind of a big number. 8 times 8 times 8. What do we get? Yeah, 12. So 8 cubed is 512. Here, we still need to clean up. We have a power raised to a power. So look in this box. 3, something similar. We have a power raised to a power. What does it say we do with our exponents? Multiply them. So all we have to do is multiply the 2 and the 3. What's 2 times 3? 6. So it becomes x to the 6. For 3 we have a fraction. Well, number 2 similar in our box. First simplify the fraction, simplify 10 over 5. What does 10 over 5 simplify down to? Okay. Well, now we have to simplify those exponents. Well, what does it say to do when we are dividing in number 2 in the box when we're dividing like bases? And we subtract the exponent. So here, and again, it's always the top minus the bottom. What's 2 minus 5? Negative 3. So that becomes 2n to the negative 3. Okay. Well, do we want negative exponents? No. Okay, so what number in that box helps us deal with the negative exponents? 5. Yeah, so let's take a look at what they're saying to do in 5. We look at 5 in the box right here. It has a negative exponent. And technically, I like to say that that's over 1. Okay? When you have a negative exponent, essentially what you're doing is you're just flipping it and changing the exponent to a positive. So we're going to say this n to the negative 3 is technically over 1. So what do we have to do with it? Flip it. So it's going to become 1 over n. And then what happens to the exponent? It becomes positive. That 2 is still hanging out there in front. That didn't change. Okay? Clean it up even more. Multiply kind of the top. 2 times 1 is what? 2. There's nothing under the 2 to change the n to the 3, so just stays n to the 3rd. Kind of a shortcut you can think about it. Whenever you have a negative exponent, so like this n to the negative 3, just drop to the bottom of the fraction. It became positive. That 2 just stayed where it's at. It didn't move because it didn't have a negative exponent. Over that one. What about 4? Well, we're multiplying, so go ahead and multiply the numbers. 5 times 6 is what? 37. And then we're going to multiply the variables. Well, if we take a look, is there any other x in this parenthesis, this second parenthesis? No, so is that x to the fifth going to change at all? No, because there's nothing to multiply it with, so it's just going to say x to the fifth. Now I'm going to kind of cross these off as we go. So it kind of helps organize my work. Here we have y. Is there another y if you multiply with it? Yeah, there's y to the fourth. And the other parentheses. So when multiplying like bases, look at the box. Number one right here. What does it say to do with our exponents? Add them. Here's the thing. What's that y being raised to? There's no exponent. 1. So when we add them, 1 plus 4 is what? 5. Scratch them out. Done with the y's. Is there anything to be multiplied with the z? Nope. So that's not going to change. It's just going to stay z. For 5, are these like bases A and B? No. So can they be multiplied together? No. So we don't think, oh, I'm just going to add the exponents. They're not the same base, so you can't do that. But what do you notice about the exponent with the A? Negative. What happens to negative exponents? We don't want them. They flip. So technically this is over 1. When we flip it, it becomes 1 over A to the what? 4. Good. Exponent becomes positive. That B to the third, did that go to the bottom at all? That's still on the top. That didn't move. It's still on the top of the 1.
Stay like that.
Yep, just stays like that. So again, kind of a shortcut. When you have a negative exponent, it just drops to the bottom, becomes positive. Anything with a positive exponent just stays in the top. You don't really need that 1 there. So you might see it on the ACT as that. The 1's not going to be in front of that piece. But they're the same thing. Questions over there? Now one more exponent rule. And I think a couple ACT questions. We look at 6. It's similar again to 6 in your box. You have a product being raised to a power, so what happens to that exponent? What did we do here when we had a product to a power? We distributed the exponent. So everything is getting raised to the 1/2. So we're going to say 9 to the 1/2. We're going to say x to the 4th to the 1/2. And we're going to say y to the negative 3 to the 1/2. Well, that's a little different. We have a fraction that's an exponent. Is there something, which number in that box kind of tells us what to do when we have a fraction as our exponent? A 4. Right? Well, when you have a fraction that's the exponent, you can rewrite it as a radical. The top number becomes the exponent, and the bottom number becomes kind of the root that you're trying to find. The square root, cube root, fourth root, your index. So here, for 9, it's 9 to the 1/2. You can also just plug that in your calculator, and it'll give you an answer. But just in case, we need to know how to do this. Write your radical. Whatever the base of your exponent is going to go underneath your radical. The bottom number of your fraction becomes your index, and the top number becomes your exponent. So what's 9 to the first power? 9, that doesn't change. And then if we're taking the square root, what's the square root of 9? 3. So this becomes 3. Again, you could have just done 9 to the 1/2 in your calculator when it given you 3. I would just do that. But just in case you know how to do that, refresh your memory. Here with this next one, we have a power to a power. Well, just like it says in the box at number 3, what do we do when we have a power raised to a power? Multiply. So what's 4 times 1/2? That becomes x squared. Here we have y to the negative third to the 1/2, again a power to a power. So what do we do with the exponents? Multiply. So negative 3 times 1/2 is what? Over. Well, again, what do we have? A negative exponent. So using that shortcut, the 3 doesn't have a negative exponent, so it's staying in the top. The x squared doesn't have a negative exponent, so it's staying in the top. But the y to the negative 3 has a negative exponent, so it's going to go in the bottom. And what happens to the exponent? You might see it like that. You might see it written as a radical in the bottom. Okay? That's why we need to know how to do it, just in case. I don't know how they're going to have the answer. So to rewrite the bottom, again, you're going to take square root. The bottom number becomes your index. The top number becomes your exponent. And your base just goes underneath the radical. So you might see it like this, like the green answer, or you might see it like that answer, either or. Depends on how they want to put the answer. I don't know what they do. Okay? Questions go from there. Okay. We have those 2 pre-test questions we'll go over really quick, and then you get time to practice. So for 31, we just want to simplify this down and figure out what the answer is. Okay, well, what's negative 9 squared? So that becomes 81. That negative still drops down. We figure out, well, negative 9 squared is 81. Keep cleaning it up. What do you notice is underneath the radical? Negative, so what do we have to take out? Good. I'll just square root it, and we take out a 9. What happens to the number underneath? It becomes positive. Okay. Well, what's the square root of 81? 9. Back on the odd. Which one matches? I mean, are you thinking, well, yeah, we normally put the plus or minus, but it can be positive or negative. There's a positive one, so that's going to be your answer. Okay. For 40, it says if n equaled 8 and 16 times 2 to the n is equal to 4 times n minus 8, then n equals what? Well, what do you think we should do with 8? Plug it in. Let's do 16 times. Equals 2. Or to the 8 minus 8. Well, what is 8 minus 8?
0.
0. Good. 8 minus 8 is 0. And as David said, anything raised to the 0 power is 1. Okay, well, we got that far. I'm thinking, how do we solve for n that's an exponent? Well, we would do what we did in the logarithm section. You have to isolate the exponential. So you divide by 16, take the log both sides, drop, it's a mess, okay? But it's multiple choice. You have the answer. What can we do? That's a job. Find a job. Pick your numbers, plug them in. Whichever one gives you 1, you're done. You don't have to do all that work. And that's going to save you time. So we can say, take A, plug it in. Plug in your calculator with 16 times 4. 1. There we go. Don't have to do any more work. There's 1. Okay? So in that situation, that is a good idea where you can plug and go. That will save you time, rather than doing it the long hand way.